Alright, General Electric Dash 7 Series Section 5 Instruction Mechanical Equipment. Alright, GE Diesel, General Electric Dash 7 Series Section 5 Instruction Mechanical Equipment. Introduction, shaft alignment, diesel engine drive accessories, description, engine to air compressor, drive shaft, air compressor, fan gear unit, equipment blower, C locomotive, hub removal, hub fitting, hub mounting, data, equipment blower, B locomotive, cab heater, description, electrical circuits, operation, safe device, removal of heater, removal of fan motor, heater element replacement, installation of heater, installation of fan motor, installation of heater element, troubleshooting. Introduction. This section covers the mechanical equipment and vendor equipment, especially for the cab heater on Series 7 locomotives. It should be noted that the variation for the equipment will exist in different models of the locomotives between railroad customers. Shaft alignment, diesel engine accessories description. The following instruction cover the alignment of the equipment blower, the air compressor for the radiator fan gear unit, the respective drive shaft. Figure 5.1. The shaft has become misaligned as a result of many natural unavoidable causes. Heat, vibration, bearing wear, settling on the foundations of basically all tending to initial element alignment. In general, coupling life is increased when the shafts are carefully aligned. If it is not done, the coupling is heavily stressed due to the unnecessary torque of the other forces. It will have a little reverse accommodate misalignment. Stress probably will not provide with the length of the surface intended. During alignment, there are two measurements to be checked: parallel and angular alignment. Figure 4.5.2. If the subbases have not been damaged, the position dowels serve to maintain the correct horizontal alignment. Alright, engine to air compressor drive shaft. Removal. The drain of the oil back from the filter to the engine free and cover to disconnect the wiring and remove the hots and lots temperature switch. Figure 5.1 engine air compressor fan gear unit arrangement. Engine drive shaft crankshaft 3 inches. Compressor sub base. Fixed dial indicator, this end, a magnet chuck. Rubber mount, the compressor, fan gear, drive shaft, fan gear unit, fan gear, sub base. Remove the long shaft guard, figure 5.3, from the engine with the compressor, the compartment bulkhead. Remove the guard with the figure 5.4 with the other compressor coupling with the compressor compartment. 4. Remove the working with the summer and winter door in the cleaning air chamber to play for the blocking under the compressor, the drive shaft to prevent it from dropping when the coupling and the compressor is separated. Also block the shaft of the engine at the engine coupling of figure 5.5 and 5.6. Figure 5.2 shows the coupling misalignment, shows the view from above, view from the front, parallel misalignment, view from the front, angular misalignment, view from above, view from front, view from parallel and angular misalignment, view from above, view from front, and end float. Locate the receptacle under each of the coupling to catch the grease with that will flow out of the coupling sleeve with the sleeves. 6. Using manpower, slide the drive shaft forward toward the engine to slide out the side of the unit until it has moved far enough to pick up the crane with slinging approximately weight completely shaft about 350 pounds. Figure 5.3 shows the long shaft engine towards the compressor guard. Figure 5.4 shows the guard over the compressor coupling. 7. Set the shaft of the floor blocks where it protected, but the repairs may be necessary. Instant alignment applied with the 16 thousandths of an inch bead of the Permatex circumferential on the flange face within the bolt circle and both coupling. Figure 5.7. Figure 5.5 blocking long shaft at the compress end. Figure 5.6 blocking long shaft at the engine end. 2. Lift the shaft of the crane, insert the shaft into the unit as far as possible, remove the sling. Note, care should be taken to keep the front of the catching hub flange on any obstacle which would cause flange or sleeve to slide off the hub at the compressor end. Several layers of electrician tape wrapped around the hub might prevent this from happening. 3. Again, use manpower, slide the shaft into the proper position to connect the couplings. Caution, extreme care must be exercised when installing the drive shaft to prevent damage for the furnished the surface of the O-rings of that flexible coupling gear hubs. Do not allow the teeth of the sleeve that some of the flexible coupling to contact the finished surface of the gear hub. If the surface is damaged, the finish may be restored by cleaning the Nalco and then the silver soldering scratches, even the flux for the silicone torch forged with the polishing of the surface of 150 grit emery cloth for the contour, crocus cloth for the finish. If the scratches are very shallow, over several thousandths, they may be removed from polishing the surface of the crocus cloth, omitting several silver soldering operations. 4 install flange bolts emitting one end at each end of torque of the bolts to 280, 310 pounds of foot torque. 5. Mount an indicator on the engine and the compressor for the coupling flange utilizing the empty bolt hole of the rotated the shaft 360 degrees. Indicate the total of the indicating run out with a taken 3 inches from the hub is to be within the 5/100ths of an inch of the figure 5-1, 5-8, and 5-9. Remove the indicators, insert the torque final bolt, lubricating coupling, turning the shaft until the pipe plug with the horizontal, then remove both the plugs, insert the grease fittings in one hole pump and the pump GED50 E21, grease it until the coupling comes out of the other hole. Remove the grease and fitting and then reinstall the pipe plugs. Your air compressor removal: drain the water and the oil from the compressor. Disconnect all the piping, the water, oil, and remove the air intake filter housing and the filters. 3. Remove the guard over the engine to compressor drive shaft with the coupling, the guard cover, and the oil pan under the fan gear with the coupling of the drive shaft. 4. Remove the bulkhead between the air compressor chamber and the fan gear unit chamber. As remove the door post for the support for the bulkhead as on the left of the side of the unit. Remove the section of the handrail with the immediate area. Figure 510. Step 5 for the removal of the air compressor. Working through the summer and winter door in the clean air chambered plate for the blocking under the compressor of the drive shaft to support it when the coupling at the compressor is separated with the figure 5-5. 6. Support the compressor for the fan gear unit coupling the shaft using a light chain sling rope between the shaft and the wire grill above it in figure 511. Separate both couplings to protect the rubber donuts and the fan gear unit coupling from the oil and dirt. Place the receptacle under the compressor coupling to catch the grease that will flow out when the coupling is separated in figure 512. Remove the compressor mounting bolts, shims, and dowels. Dowel can be removed by the putting of the several washers on the pin between the compressor foot and the dowel and run the nut. Tighten the nut down until the dowel releases, and then mark the shims when removing them so they can be reassembled in the original position when the compressor was reinstalled. 9. Figure 7. Application of Permatex bead on the flange. And 9. Slide the compressor onto the mounting base onto the side of the unit, which is removed. Blocking must be adjacent to the mounting of the base, extending out of the way of the walkway through far enough that the overhead crane, hook, and cable will clear the radiator overhang to be hooked with the lifting eye on the compressor. 10. Lift the compressor from the unit. Installation and alignment. 1. The shrinkage of the coolant coupling hub of the compressor input shaft C-hub mounting section. Figure 5-8, indicator mounted on the engine coupling. Figure 9, indicator mounted on compressor coupling. 2, mounting the compressor onto the sub base. If them replacing same machine alignment with the dowel holes located on each side of the compressor with those in the sub base. All shims will be removed during the air compressor removal. The air compressor during the compressor removal must be reinstalled in their original positions. Note: if the machine has been in the same one removed, the step 2 should bring the machine very close to the original alignment if the new one rebuilt. Figure 10, with the view of the bulkhead and doorpost handrail removed. Figure 11, supporting fan gear unit shaft compressor. If the new or built compressor is being installed, shims may have been added. Some of the original shims removed to obtain proper alignment. Also, the dowel holes make the required plunging before re-drilling. Place the compressor drive shaft coupling into the position for the assembly of the compressor coupling. Lubricate the threads and flange bolts with Molykote GN. Install with the coupling torque bolts at 280 to 300 pounds per torque per foot. Figure 512 shows the location of receptacle of the catch grease. Install the dial indicator on the engine coupling. Figure 513 and one of the compressor coupling. Figure 514 indicate the shaft of 3 inches from each of the hub. Rotate with the shaft 365 degrees. Read and total them run out. Total run out with the fuel tank should not exceed 5/500ths of an inch, and refer to figure 515 for the fixture. When run out with the step 5 that has been obtained, lubricate the thread with the compressor bolt with the Molykote GN. Install the bolts and tighten them to 400 to 450 pounds of torque. Insert the dowel pins into the original holes aligned with the ream and install the oversized dowels. 7. Rotate the shaft until the grease plugs opposite each of the other end of the coupling horizontal. Remove the bolt plugs. Install the grease fitting in the one hole. Insert the grease in GED50 E21 into the coupling until it comes out of the other hole. Remove the grease fitting and then apply the liberal coat of Permatex into the pipe plug threaded with the install of the pipe plugs. Your fan gear unit removal. Remove the radiator compartment hatch from the radiators. Disconnect the gear unit with the coupling. Remove the mounting bolts and dowel shims. Mark the shims so they can be reinstalled into their original position. 4. Remove the bolt end of the fan shaft and insert the lifting of the eye bolt. Figure 5.13 shows the checking alignment between the drive shaft and the diesel engine. Figure 5.14 shows the checking alignment between the drive shaft and the compressor. 5. Lift until vertical. Make sure the fan does not catch on the shroud. Installation and alignment. Note, do not attempt to align the fan gear and unit with the air compressor without first obtaining the proper alignment between the engine compressor. And when the correct compressor alignment has been achieved, proceed as follows. Shrink the hub of the fan gear unit shaft and onto the compressor output shaft. See the hub mounting section. Figure 5.15 shows the indicator holding mixture of fixture alignment over the alignment of the compressor drive shaft. Or shows the fillet weld, the tack weld, and lock washer nut with a weld and a 1/4 inch by 1 inch bolt on all dimensions in inches. Bends and twists 90 degrees, okay? 2. Install the drive shaft of the fan gear unit shaft, the hub, lubricate the bolt threads with the Molykote GN tighten with a 280, 310 pounds of torque. Mount the fan gear until the unit is on the sub base. Replace the shims as they were prior to the removal to maintain 3 to 3 and 3/100ths of an inch between the hubs and 3/8 of an inch. Between the ends of the fan blade and fan shroud or opening. Note, if the unit is being installed with the same one, remove step 3, which should be bring the end unit very close to the original alignment. If the new or rebuilt is being installed, the shims may have to be adjusted to obtain proper alignment. For mounting an indicator large compressor coupling flange with an indicator with the outside diameter of the gear unit flange, rotate the fan gear flange with a check the total runout. Total indicator the runout should not exceed 1/100th of an inch. Figure 5.16 and 5.17. Clean out the bolt hole in the rubber nuts of the mounting sandwich. Leave the correct length of the bolt to prevent mounting on the bolt prevent bottoming the bolt and pulling out of the nut, tightening the mounting bolts. Install the rubber mounts lubricated with the bolt threads with the lubricator plate and tighten to 28 to 30 pounds foot torque. No, when tightening the bolts, avoid twisting rubber nuts. Molded lines on the mount should be visibly straight after tightening. Do not over torque. Reassemble any rubber mount on the shows greater than 3 degrees or 0.08 of an inch and twist in either direction. Assembly figure 5.18. 5.17 shows the indicator mounting. Show with the compressor end at 1/2 inch with a sandwich mount at 3 inches to 3 3/100ths of an inch. Maintain this dimension. The gearbox end and the file on the fixed dial and the indicator this end magnet clutch. So the total indicator reading through the 1 revolution of the coupling is 15 thousandths to 5 A, and B would be 5 thousandths of an inch. Figure 5.17, checking alignment between the compressor and fan gear unit. 6. Mounting the indicator shown in figure 5.17, 5.18, route the fan shaft 30 60 degrees to check parallel angular alignment. Total parallel indicator reading should be within 15 thousandths of an inch. Total angular indicating reading should be between 5 thousandths of an inch. Note, to reduce the compressor torque and pressurize the compressor underloader value. So after obtaining the proper alignment, bolt down the fan gear using the lubricator plate on the mounting bolt threads. Tighten the bolt to 200 to 250 pounds of torque. Install the dowel pins, the original holes and ream holes. Install overside dowel bolt pins. Equipment blower C, locomotive removal. As prescribed in the intervals, equipment blower must be removed to inspect the bearings using the following procedures. Remove the blower hats. Figure 5.18 shows the cross section of a rubber mounted mounting sandwich. Rubber in the molded lines. 2. Remove the bolted in section bulkhead around the blower drive with the coupling with the generator compartment. Disconnect with the flexible coupling with the remove the 2 bolts at each end of the coupling, figure 5.18. 4. Remove the dowel pins and blower mounting bolts and make and save shims since they must be replaced in the original position upon reinstallation. 5. Insert the lifting eye and lift out the blower. Installation alignment. Shrink the hubs onto the power or take off the shaft and the blower shaft. See the hub mounting section. 2. Mount the blower on the sub base. Align with the dowel with the holes. Replace the shim. Remove the during removal over the blower. Note, if the blower is being installed in the same one, the remove step 2 should be bring the blower close to the original alignment. If new or rebuilt blower is being installed, shims may be adjusted to obtain proper alignment. 3. The coupling must be as disassembled for the installation. Remove the 2 bolts on both ends with a screw with the coupling flange with the flex pack of the coupling hub, figure 5.19. Bolt these flanges with the blower of the power takeoff hubs. Torque the flange mounting bolts to 30 to 35 pounds of torque. Clean the bolt nut and thread with safety solvent in the wipe drive with applied Loctite sealant into the bolts with a screw into the flange. Assemble the bolts and immediately torque or 4 bolts at the end of each coupling at 115 to 120 pounds of torque. Figure Figure 5, 19 shift of the blower coupling removed, and 5 mounted on an indicator each for the hub and indicated at 5-inch on the shaft at each end. With the figure 5, 20, adjust the shims under the blower until the total indicator run out with a 2/100ths of an inch within the fuel tank. See figure 5, 21 for the fixture. When proper alignment is obtained, bolt down the blower using a lubricator plate with the bolt threads for the tightening of the bolts at 200 foot-pounds of torque. Install the dowel pins original hole with the alignment with the ream holes. Install the oversized dowel pins. Replace any guards which had to be removed to facilitate removing the blower. Hub removal. Using a hydraulic pump, coupling hubs may be removed with the pop-off or the float method using the hydraulic pressure for the quick removal. Steps 1 through 5 may be used to remove all the hubs where the shaft ends are properly prepared. To see the tool catalog for the proper tooling, use the same hydraulic pump and the adapter employed to float traction motor pinion. If locking a nut assembled at the end of the shaft, loosen the set screw with the screws of the back off the 1/4 inch to 1/4 to 1/2 turn 2 active the backup plate with when the hub pops off. And 2, insert the adapter in the thread hole into the center of the shaft, connecting it with a tubing to these hydraulic pumps. Caution, do not heat the hubs before removal and using a steel hammer to drive the hubs off the shaft. Damage to the equipment or shaft may result. Figure 520 shows the equipment blower flexible coupling bolts 5 inches, the hub bolts, the blower shaft hub, the spacer, a flex pack, and a coupling hub. Figure 521 indicator holding the fixture alignment of the equipment blower with the power takeoff shaft. All dimensions in inches, 1/4 inch, 2.5 inch, 1 inch weld, 1/2 inch, 1/4 inch round rod welded in the 1/4 inch end nut weld. Alright, pump up with enough pressure to force the shaft of the groove with a 10 to 20 stroke for the normal sufficient hub to remove the pump assembly from the shaft. 5. Remove the nut and slide hub off the shaft. Follow the hub assembly carefully. Inspect all the parts paying particular attention to the internal external gear teeth and the O-rings. Excessive wear of the gear of the teeth will require installation of the new parts. If the hub and sleeve are renewed, install the new hub sleeve with its spare. Do not mate the new gear hub as a worn sleeve, the vice versa. Using a mechanical puller, 2 hubs of the equipment having shaft ends when not prepared with a hydraulic float method must be removed using the hub puller tool. Hub fitting. To prevent the hub from slipping, it should have at least 75% of the shaft. This is at least 75% of the tapered board with the hub that is contact with the tapered fit on the shaft before heating the hub for the mounting and checking the correct fit as flows. 1. Lightly cover the hub board with a bluing compound such as a Prussian blue oil pigment. 2. Snap the cold hub off on the shaft. Do not twist the hub after it's placed. 3. Relatively position the hub on the shaft with the chalk and then remove the hub. Insert the taper fitter on the shaft, bluing the hub bore with show you have transferred it to, and should now show on the shaft that it has at least 75% of shaft surface show traces the bluing and to the fit is satisfactory. If, however, the only a few spots of bluing show on the shaft, the fit is insufficient. 5. When necessary, dress down the blue spots on the shaft very lightly using an emery cloth. 6. Blue the hub again in step 1 with the wiping blue off the shaft end. Repeat the steps 2, 3, and 5. Be careful to place the hub on the shaft in the same position as indicated by the chalk marker. To fit generally will be improved, but the procedure given in step 1 through 6 may have the repeated several times. Caution, under no circumstances using lapping compounds, since lapping will produce the shoulder at a large end of the tapered fit. The shoulder will be prevent the perfect fit when the hub is mounted into the advanced position. Hub mounting. Proper hub mounting is essential for the successful operation of the coupling. Proceed as follows. Thoroughly clean the hub to fit when the shaft and the bore of the hub. Note, do not use the kerosene or other cleaner will leave an oil film. Remove any scarfing on the shaft of the hub bore. 2. Spot the cold hub on the shaft by hand and check for 75% fit of the hub fitting section. 4. Trailer mount on the hub on the shaft. Measure and record the position of the hub with respect to the shaft. Make measurements of the micrometer or pinion advance gauge. Mark the pinions and measurement across the end of the shaft and the hub face so that the hub, when heated, can be mounted exactly the same angular position. And the advanced measurement can be made from these same points. 5. Heat the hub in an oven until the entire hub is reaching the uniform temperature as specified in the data section. Some of the accurate method must be made to measure the hub shaft and temperatures quickly before mounting the hub. This can be done least with best by the pyrometer. See tool catalog figure 522. Measure the temperature of the shaft and the hub in the same instrument. Quickly mount on the hub shaft of the hub on the shaft of the same and angular position as when cold, using the chalk markers as the guide. When the hub is readily in engagement with the tapper fit, not in the actual contact, snap it forcibly into place with a quick push. It's important the hub instantly snapped into position before it is cooled. Applicability otherwise it will freeze to the shaft and will not further adjustment. Figure 523 shows the hub being mounted on the shaft. No, the coupling sleeve and the O-ring must be placed over the shaft before the hubs are installed. Check the hot or shrunk-on position of the hub on the shaft of the gauge located on the same relative position. Use to measure the position the hub was heated. Proper advance is shown for that data section if the advance was not within the limits given in the hub. Repeat the procedure in figure 524. Show the hub and advance being checked. Insufficient advance can result from not soaking the hub in an elevated temperature for the sufficient time or not having the high temperature high enough. Remember that the temperature shown on the data section is the difference from the oven that should be above the shaft temperature, and sufficient advance can cause slip coupling. Less often achieved, but just a great problem is in case of the other overt advancement. This can cause cracked hubs and resulting failure. Figure 522 shows using a pyrometer to check the hub temperature. Figure 523 shows applying the heated coupling to the heated coupling hub to the compressor drive shaft. Alright, your data, your hub to transfer cab fit, compressor drive shaft hub 75%, compressor input to output hub 75%, fan gear unit hub 75%, blower hub 75%, power takeoff shaft hub 75%, temperatures, degrees above shaft temperature required for the proper hub advancement. Advancement in inches and temperature. Compressor drive hubs 35,000 to 40 thousandths of an inch. Compressor input 35,000 to 4 thousandths of an inch. The first one was 214 to 235 degrees Fahrenheit. Compressor output hub 30,000 to 35 thousandths of an inch, 225 degrees, 212 degrees Fahrenheit. Fan gear unit hub 35,000 to 40,000 of an inch, 235 degrees Fahrenheit. Blower hub 50,000 to 55,000 of an inch, 355 degrees Fahrenheit. Power takeoff hub 40,000 to 45,000 of an inch, 275 degrees Fahrenheit. Engine torque, engine to compressor alignment with the fuel tank's fuel in inches. Total run out in 3 inches from the hub is at 5 hundredths of an inch. End play of the free to 5 tenths of an inch. Compressor to fan gear alignment in inches. Parallel alignment run out 15,000 of an inch. Angular alignment 2.5 inches. Radius from the center line 1/100th of an inch. Blower in alignment with the fuel tanks and total run out 50,000 of an inch. Torque values per foot in pounds of torque. Compressor drive shaft coupling flange bolt 280 310. Rubber sand switch mounting bolts 28 to 30. Blower coupling flange bolt mounting bolts 30 to 35. Blower coupling flange bolts 80. Compressor mounting bolts 400 to 450. Fan gear unit driving flange bolts 280 310. Fan gear unit mounting bolts 200 to 250. Equipment blower mounting bolts 200. Alright, figure 524 shows checking the hub advancement. Equipment B locomotive. Note the equipment blower on the B locomotive is located with the radiator compartment. The rotor over the blower is mounted with a subshaft of the fan gear unit. Since the fan gear unit is driven with a diesel engine, the blower will operate whenever the engine is running. Therefore, since the rotor is mounted on the stub of the shaft of the fan gear unit, the shaft alignment procedure is not necessary. Removal. If there any reason for the removal of the fan gear unit, the figure 525 and the 526 is required to rotate rotor must be removed from the fan gear unit shelf of the blower. The housing must be slid off the rear of the radiator cap. To do this, proceed as follows. 1. Remove 6 bolts and holding the inlet guard to the place for the remove of the guard. 2. Remove the 16 nuts holding the inlet cone to the housing and remove the cone. 3. Remove the rotor as follows. A. Remove the 2 Allen head mounting screws. B. Insert one of the screws in the jacking removal hole. Torque down and bushing does not loosen. Tap the rotor hub while applying the torque on the screw. C. Slide the rotor with a stub shaft on the end of the housing. Alright, 4. Remove the dowels of the blower mount flange and blower support. 5. Remove the housing mounting bolts sliding out of the way of the house. And mark the shims removed so that they may be placed in the original position where the gear unit is reinstalled. Figure 525 shows the equipment blower assembly. 1 is the housing, 2 is the inlet cone, 3 is the inlet cone mounting bolts, 4 is the inlet guard, 5 is the housing mounting bolts and shim, 6 is the seal, 7 is the hub and bushing, 8 is the rotor, 9 is the inlet guard bolt. Figure 526 taper lock and hub bushings. The mounting screws A and it shows the A. Remove the holes from the mounting screws. Mounting position. Removal of the piston. Remove mounting position. Removal position. Hub and bushing in section A. Cross section A and A. Installation. When the gear unit is installed with the line with the compressor for the indoor engine, proceed as follows. Be sure the blower support with free of the dirt and oil to clean with the solid solvent and the mineral spirits D588. And seals blower support with the damage, replace them by activating adhesive to new seals using safety solvent and applying with the new seals of the blower support. 3. Position the blower housing with the line with the dowel pins. Replace dowel holes. Replace the shim with the original position on the blower support line to 5.5 inches diameter, opening the housing with the fan gear unit shaft to 6/10 of an inch, plus or minus 6/10 of an inch on the radius. Line the inlet side of the blower housing within 17.03 0 or to 16.970 of an inch vertical horizontal to the end of the shaft. Sweeping tool figure 527 and 528. Mounting housing in place torque. Mounting bolts at 180 to 215 pounds of torque. Assemble the router as follows. Clean the fan gear unit shaft key and fan hub. Bore the mineral splitters. Make sure that the clear is completely removed before assembly. Polishing the surface with clean paper towels is recommended. Inserting the bushing in the hub, matching the haft holes. Figure 527, the making sweeps tool measurements. Figure 528 shows the sweeping tool, also the screw and the diameter, the bore holes, and the hub, the tap holes, and dimensions. Coat the set screw with the oil, insert those loosely in the two holes, and then threaded with the hub side of the hole. D. Slip the fan assembly onto the shaft with the key and the keyway. The E. Tighten the hub bushing screw alternately to 800 pounds of torque. And hub face should be flush with the shaft end within 0.02 of an inch. Hammer against the last edge. Hammer against the last. Hammer against, tighten the bushing with the alternately with 800 pounds an inch is in torque, and the hub face should be flush with the shaft end of the 0.02 of an inch. Hammer against the large and bushing end of the hammer and the brass block on the sleeve to avoid damage. Retorque the set screw. Repeat the alternate housing, hammering, screwing, tightening until the specified wrench torque no longer turns. The screw. Fill the other holes with the grease and exclude the dirt. Replace the inlet cone with using caulk between the housing and the cone. Adjust the cones to the dimension between the rotor and the cone. Figure 5 to 25 of the mat. Tighten those 16 nuts. Place the inlet guard with using the caulking between the cone and the guard, tightening the 6 bolts. After alignment, drill and ream the 2 holes to 5/110 of an inch. Although through number 2 end blower mounting flange and blower support, insert the new dowel pins. Or your cab heater. The description of the cab heater is self-contained with electrically heated the locomotive cab located in the short hood with the cab house for the heating elements of the motor and blower with the overheat the switches and terminals for the external power connectors. Connections. Cab air enter through the lower opening of the cab front wall with the low of the blower. Return with the heating elements through the cab through the upper opening. Clean air from the platform for the air duct. Control with the fresh air leveler. Figure 529 on the left shaft of the heater may also be introduced to the heater and air shaft. The heater has 5 heating elements capable of delivering 11.25 kilowatts of heat overheating switch, which is manually reset percent. Pressing a red button on the top of the switch can be reached from through the hinged access door on the left side of the heater. Figure 530 to prevent overheating of the cab. Return the thermostat, which opens at 100 degrees Fahrenheit, resets the automatically to 90 degrees Fahrenheit, incorporated with electrical circuits. Heater opens at 74 degrees volts DC. Heating elements are rated between 2250 watts to 74 volts. 2-speed blower motor is rated at 0.167 at 0.220 horsepower, 860 to 1160 RPMs, 3 to 4 amps, and 74 volt DC. Motor speed is varied by switching 100 ohms to 100 watt field resistor. Figure 529 show the heater air inlets outlets. The cooler air and fresh air, 4-inch hose connection, hot air discharge, access door, thermo switches, control wiring. Alright, figure 530 show the top remove swirling thermo switches. Press reset button red, manual reset, automatic reset. Electrical circuits, because several modifications of the original heater attention is called to necessity working through the correct circuit. Diagram is connecting the surface of the heater. If the heater circuit matches the figure 331 and 332, 531 and 532, contact the GE service man for the necessary equipment to update the heater to the latest schematic diagram 533. 531 showed the motor, resistor, a switch gate on another kilowatt resistor field coil current, three load coils on pole 1, pole 2, and pole 3 with a 110 amp, 70 amp, and a 100 amp and a trip coil to a trip coil and resistors. Current. Figure 532 shows the cab heater schematic. You have you got a diode, you got a field currents, SD1, resistors, a motor, 2 cab heat blower, a cab heat low heat, operation. Close the circuit with a HB1 and HB2 figure 533 with locating the toilet compartment. So set the cab heater switch. Set at the blower only position with this position with the contact 6 closed, allowing the fan motor to run with the full speed at 1160 RPMs. The cab heater switch set for the low heat. Contacts 2, 5, and 6 are closed and causing the fan motor to run heat that reduced at 860 RPMs. With the cab heater contactor 1 picked up the 4.5 kilowatts heater element is energized, furnace the low heat of the operator's cab. When the switch of the cab heater switch is set at medium heat, the contacts are 3 and 6 closed, causing the fan motor to run high in speed. With the contactors of the contactor heat contactor 2 picked up with a 6.75 kilowatts heat element, energized, furnishing medium temperature heat of the operator's cab. When the switch of the cab heater switch is set with a high heat, the contacts 3, 4, and 6 are closed, causing the fan motor to run at high speed. The contactors heat contactor heat current 1 and 2 picked up both 4.5 to 6.7 kilowatts heater elements, energized, furnish high temperature heating the operator's cab. Or 6 with the heat switch from the heat position, air is circulated through the cab through the heaters back into the cab outside in desired small lever. Figure 33 shows the cab heater switch. Second modification. This shows we'll start at cab heater control, cab heater contactors 1 and 2. We have resistors which show the 4.5 to 4.5 and 6.7 kilowatts running into the section 1, section 2 hub and the hub. Got a cab heater switch 1 through 6 in here. Motor. Figure 529 protruding with the lower left side of the heater may be moved right to the open hole with the slide along clean outside of the air to make sure the inside air meet maximum heat flow. Safety devices: when there are 2 thermal switches, the figure 30 with an electrical section with automatic reset, other manual reset. Switch. The temperature reaches the 100 degrees Fahrenheit automatic reset thermometer opens to de-energize the heat pressure relay HPR and in turns contacts cuts the power of the heaters de-energizing contactors CH1 CH2. Fan motor will still run high speed with the temperature it drops 90 degrees Fahrenheit and will switch to the automatic reset. Should the automatic reset thermal switch fail, with the temperature reaching 200 degrees Fahrenheit, the last switch opens and the edge. Again, the power is cut off of the heaters to reset the switch. Open the door, remove the cover to the left side of the heater housing, remove the throw through the trough over the heat elements, press the red button down with the thermal switch. Warning, this area around the surrounding metal may be hot, therefore care should be taken to prevent getting burned. Latching switch with the trip and invisible check with the heater thermally determine why 100 degrees Fahrenheit switch did not trip, replace it if found defective. Or removal of the heater. Remove the hatch on the short head of the nose nose of the cab. Disconnect 4-inch hose of the air inlet pipe at the bottom of the heater. Remove the 2 half-inch by 13 half-inch 13 1.25 bolts holding the heaters at the bottom of the mounting brackets. Move the top side cover and the opening hinge door on the left side of the heater and disconnect and temporarily insulate the power supply cables. Remove the 5.5 by 5.5 inches plates on the top heater of the housing and attach the slings to the carrying hook to lifting the lugs provided inside the housing. Take slight strain off the sling and remove the half-inch by 13 1.25 bolts secure the top heater with a bulkhead. Carefully lift the heater out from the locomotive. Removal of the fan motor. Remove the heater from the locomotive, then remove the wrap around the top end of the side cover. Loosen and remove the second screw holding the fan over the motor shaft. Disconnect the motor leads at the motor. Remove the 6 mounting screws holding the motor mount to the heater housing. Pull the motor from the unit. Fan will remain in the unit. 5. Loosen the bolts in the mounting bracket and band and remove the motor from the mounting bracket. Figure 534 of the motor brackets and heating elements. Show the blower motor, the mounting bracket, motor mounting bracket, the pail nuts, the heater elements, the power terminal block, the resistor for the 2-speed operation, and lifting lugs. Heater element replacement. Figure 534. Remove the heater and fan motor from the locomotive, then disconnect the leads elements to be replaced. Remove the pail nuts, washer holding elements in place. 3. Slide elements out of the unit. Installation of heater. With the crane, carefully lower the heater into the nose of the cab. Guide it to the set on the lower mounting brackets with the mounting line. Insert with the tightening of the 2.5 inch by 13 1/4 inch bolts. Align the slot with the top of the heater with the holes of the bulkhead. Insert the tightening 1/2 inch 13 by 1/4 inch nut bolts. Insert the power cables in the heater with a connector with a schematic diagram. Remove the sling. Replace all the cover previously removed. Reconnect the 4-inch air intake hose at the bottom of the heater. 6. Reinstall the nose cab hatch. Installation of fan motor. Reverse removal procedure. Installation of heater element. Reverse set of the removal elements. Troubleshooting. Using troubleshooting table to 5.1 will help you identify the possible cause of the trouble. Once it caused, determine the procedure for eliminating it. Will must case the event because of the power to operate the cab heater supply with the locomotive auxiliary generator unit cannot be operated unless the engine is running. Heater may be operated in the shop supply with a 74-volt DC power. Control switches, breakers must be supplied for the off locomotive operation. Fan won't run. Possible cause: fan motor circuit breaker. Correct wiring. Motor brush faulty. Correction. Replace brushes. Blower wheel block. 3. The blower wheel. Fan speed excessive. Open field circuit. Correction. Correct circuit. Close correct circuit and replace motor. Fan speed excessive. Overspeed. Open resistor is set on the high speed. Replace resistor. No heat. Fan running. Overheat switch trip. Reset the overheat switch. Over wiring and heat circuit. Correct wiring. Defective hand heater interlocking circuit. Correct the circuit. Defeating the defective heating element. Replace the elements. Low heat, lower than normal. Open wiring into one more elements. Open defective heating element. Possible cause. Unit overheats when fan on low and high speed. Airflow restriction on one of the following. Open circuit on the overheat switch wiring. Correct wiring. 2. Breakers contactors fail to open on signal. Repair and replace breaker on the contactor. Overheating switch failed. Replace the overheating switch. And that completes Step 5 of the GE-series instructions, Section 5, Mechanical Equipment.